alaikum wa rahmatullah. Good day, everyone, and welcome to my YouTube channel where I solve physics problems. In today's problem, we will look at the capacitance of a parallel plate capacitor. This is a special kind of capacitor where you have two conducting plates of equal area placed parallel to each other at a certain separation. You have a conducting plate here. This is plate, and then you have the second plate here. For example, the two plates are of equal area. Okay, uh, area A. This one also has area A. Okay, let us call this one plate A, and then this is plate B. Now, if you connect this to the positive terminal of a battery, then this plate will store positive charges, and the magnitude of the charge is plus Q. Again, if you connect the other plate to the negative terminal of the same battery, then this plate will store negative charges. The magnitude of the charge is negative Q. Okay, now here you may use an insulating material here. Okay, an insulating material here. The insulating material used here is called dielectric. Now, because this is positively charged and this is negatively charged, there exist lines of electric field running from positive to negative. So there is electric field here in between. This plate that is positively charged is at high electric potential compared to this plate that is negatively charged. After some time, the voltage of this battery becomes the potential difference between the between the two plates, V. Okay, to find the specific formula for the capacitance of the capacitor here, okay, we did not identify the separation between the plate. Okay, is also important. D is separation. D is separation between plates, meaning the distance between the plates. Okay, we will start with the general formula. The general formula says that the capacitance of any given capacitor is charge divided by V. For this particular one, this charge means the charge on either plate, because the magnitude of this one is still Q, the magnitude of this one is still Q. So, and V is the potential difference between the plate. Now there is a relationship between the potential difference, the electric field, and the separation between the plates. The relationship says that this electric field strength is given by the PD between the plates divided by the separation between them. So I'm going to keep this one as equation 2. There is another formula for obtaining this electric field. It said sigma divided by epsilon. Epsilon is permittivity of the medium. Epsilon is a constant called permittivity of the medium. What is meant by this here is that this epsilon depends on the kind of dielectric you use here. We are going to see that later. Now, you may be curious to ask, what is this sigma? What does it mean? This sigma is called surface charge. Surface charge density. It is called surface charge density. It is given by the total charge on either of the plate. If you take plate A, the total charge on plate A divided by the area of the plate. This is what we call surface charge density. Now if you substitute Q upon A and then you divide it by epsilon, then this will be Q divided by epsilon A, and we call this equation 3. We call this equation 3. Now if you look at equation 2 and equation 3, equation 2 and 3, they have the same left hand side, electric field, electric field. It means that their right hand side must also be the same. So we say this implies that we take the right hand side of equation 2 and say V upon D is equal to the right hand side of equation 3, Q upon epsilon A. Next we multiply both sides by the denominator D. If we do that, then this D cancel D and we have V is equal to Q times D, QD upon epsilon A. Now we can take the reciprocal of both sides. If we do that, we divide this by 1. The reciprocal of both sides, this will be 1 upon V is equal to the reciprocal of this is to bring this up and this down. So we have epsilon A upon QD. Okay, having established this, you can see that we can substitute this 1 over V into equation 1 here to get our formula for C. Let's do that. Equation 1 says that C is equal to Q upon V. I can rewrite this as 1 over V times Q. And then remember, we established 1 over V as epsilon A over QD. So this is equal to, instead of 1 over V, we now substitute epsilon A upon QD, and this should be multiplied by my Q. Clearly, we see that Q cancel Q, so we have this is equal to epsilon A upon what? Upon D. So in conclusion, our C is equal to epsilon A upon D. This is the capacitance of a parallel plate capacitor. I said this one depends on the medium you put here. Okay, and there is a formula that says this epsilon is equal to epsilon sub r epsilon naught. We call this relative permittivity. This one relative uh, permittivity and this one is permittivity of free space. Free space means vacuum. So if this this separation between the plates, you did not put anything here, in fact there is no air at all in between, then it becomes a vacuum. And when it is a vacuum, your relative permittivity is 1. That is epsilon sub r is 1. If you put 1 here, then you will see that epsilon becomes epsilon naught, permittivity of free space. That is when you have vacuum in between the plate, and this now becomes C is equal to epsilon naught A upon D. That is for free space. Now let us try and understand this formula. This formula tells you that the capacitance of a capacitor increases with area of plate, because area of plate is a numerator here. So if this area increases, okay, the capacitance of the capacitor will also increase. It increases with increasing area. Then if you want the capacitance to increase, you have to decrease you have to decrease the distance between the plates, meaning that you bring the plate very close to each other so that this D is very small. When you do that, you are increasing its ability to store charges. Okay, it will store more charges. Again, if you make the plate large, this makes sense, it will store more charges, so capacitance increases. In a nutshell, capacitance of a parallel plate capacitor increases with increasing area and decreasing separation between plates. Okay, next we are going to look at some examples on how to use this formula we have just established. Okay, it says problem solving on the capacitance of a parallel plate capacitor. Problem 1, we have problem 1. Problem 1 says the plate of a parallel plate capacitor, each of area. So you are given the area of plate. So we now say solution. Our A, we are given A, and this A is, look at A here, 0.6 meters squared. It is in the SI unit, so we don't have to convert. Are separated by this. So this is the separation between the plates. Remember, we give it letter D. So our D is equal to 2 millimeter. So this first M means 10 raised to the power of minus 3. So we convert that and say times 10 raised to the power of minus 3 in meters. Calculate the capacitance of the capacitor. And then they say take epsilon naught as this. 8.85 by 10 raised to the power of minus 12 farad per meter. So let's write that epsilon naught equals 8.85 times 10 raised to the power of minus 12 farad per meter. Okay, we now write the formula. Of course, our capacitance, the capacitance of the capacitor is epsilon naught A divided by what? Divided by D. Okay, then we substitute the values. Epsilon naught is this one, so we open bracket and say 8.85 times 10 raised to the power of negative 12, and then our area of plate is okay, this is farad per meter, and then area of plate is 0.6 in meter square, and divided by D is 2 times 10 raised to the power of minus 3 in meter. Okay, here we see that the meter here will cancel one of the meters here, and then this meter will cancel the other one, so you only have farad as the unit of capacitance. Okay, now we bring our calculator. How do we press this? 8.85. Okay, this is a calculator. We press 8.85 exponential negative 12, and you see it appearing here, exponential negative 12. Then you multiply this by 0.6, so 0.6. You divide your answer by 2 exponential, okay, 2 exponential negative 3, and this will give us 2 point, wow, this is 2 is, as you can see, okay, is 2.655 times 10 to the power of minus 9. So we have 2.655 times 10 to the power of minus 9 in farad. But 10 to the power of minus 9 is nano, so we can simplify this and say 2.655 nanofarad. That's it. We got we solved the first problem. Then we move on to the second problem. Look at the second problem. The second problem says that the capacitance of a parallel plate capacitor is 40 microfarad. Bring out the parameter you are given. The first one, this is your C. If the plates are separated by this, okay, this is your D, small d. Calculate the common area of plate. Your target variable is common area of plate. Target variable is the one or the parameter you are asked to calculate. We call that target variable. So let's bring out what we are given. C is 40 microfarad, and this is 40 times 10 raised to the power of negative 6, because micro is 10 raised to the power of negative 6 in farad. Then you are given D, and D is equal to 0.3 millimeter. So millimeter is not the SI unit. The SI unit is the meter, so we convert it. The conversion factor for milli is 10 to the power of minus 3. Now it is in meter. Okay, we are given epsilon naught 8.85 times 10 raised to the power of minus 12 farad per meter. Okay, what is our target variable? Our target variable is area of plate. So we write the formula. C is equal to epsilon naught A divided by D, and we make A the subject of the formula. How do we do that? First, we clear the fraction. Simply multiply both sides by d to clear fraction. When you do that, d here will be cd, and this is equal to d cancel d epsilon naught a. Next, divide both sides by epsilon naught, or divide both sides by epsilon naught by epsilon naught. When you do that, you see that here you are left here nothing cancels, so you have cd divided by epsilon naught is equal to this cancel this a. So a is now the subject of the formula, so we rewrite this as a is equal to cd upon epsilon naught and substitute the values we are given. C is this, you see, you are given C as 40 times 10 raised to the power of negative 6. That is your your C in farad. Then your D is 0. Look at it here, 0.3 times 10 raised to the power of negative 3 in meters. Then divided by your epsilon naught. Your epsilon naught is this, so it's a constant. You will always be given 85 times 10 raised to the power of negative 12 farad per meter. Okay, before we move on, you can see that this farad cancel farad here. This is per meter. When it comes up here, it becomes meter, and meter times meter will be meter squared, so you get the area in meter squared. Okay, let's solve this. Let's press that in a calculator. You press 40, then exponential negative 6. This is the negative, and this is the 6, and see what appears here. Then you multiply this by 0.3. Okay, 0.3 exponential negative 3, and you see this is what appears. Then you divide this by what you have here. Down here you have 8.85 exponential negative 12. Okay, now you can press the equality sign. Oh, I have it in fractional form, so I want the decimal form, so I will just press this SD. So this will be 1, as you can see, we have 1355.9 in meter squared. Okay, this is the common area of plate, and with this we solve the second example. Then we have the third example here. The third example here says that calculate the separation between the plates. Calculate the separation between the plate. What is the separation between the plates? That is your D. So it means find D. D is your target variable from the first sentence. of a parallel plate capacitor whose values of capacitance and plate area are, you are given the capacitance, this is C, you are given the plate area, this is A, and then you are given epsilon naught. So as usual, you bring out the parameters you are given. Your C is 50 microfarad, and this is 50 times 10 raised to the power of minus 6 in farad. Then the common area of plate is 3.8 meters squared. Then you are given epsilon naught, of course it's a constant, 8.85 times 10 raised to the power of minus 12 in farad per meter. Then your target variable, you don't know D. So again, we write the formula, the relationship C is equal to epsilon naught A upon D. Now we want to get D. So D should be made the subject of the formula. The easiest way to do that, simply interchange this. Bring D here, take C there. So you now have D is equal to epsilon naught A divided by C. Okay, now you can make the substitution. This is equal to your epsilon naught first, which is 8.85 times 10 raised to the power of negative 12. Okay, negative 12 in farad per meter, close bracket, then open bracket. You have the next one is A, and A is 3.8 meters square, close bracket, divided by C, and your C is 50, you can see here 50 times 10 raised to the power of minus 6 in farad. This is D, it has to be in meters. So you see farad cancel farad, this meter will cancel one of the meter here, and you have 1 meter remaining. So your D is separation in meters. Next, you bring your calculator and say, and press 8.85 exponential negative 12 multiplied by 3.8, then divided by 50 exponential what? Negative 6. So I have the negative here, then 6, then I press equality sign. So this gives uh, 6.726 times 10 raised to the power of negative 7 in meter. This is the separation between the plate. This is extremely small, of course, it's extremely small. Now, on a final note, we have example 4. Okay, example 4 says the electric field strength. What do we mean by electric field strength? Is the capital E we use in our derivation. The electric field strength between the plate of a capacitor separated by 4 millimeter is this separation of plate is this. So the electric field is finally given here, E. So you are given the electric field between the plate, the separation, and then you are asked to calculate the potential difference between the plate. Clearly, you don't need this formula that says C is equal to epsilon naught A upon D. You don't need this formula at all. The formula you need now is the one that says that electric field is V over D. This is the one you need. You need a formula that relates electric field to separation and to potential difference. Potential difference is your V. So we bring out the formula. We are given the parameters we are given. We are given electric field, and electric field is 120 volt per meter. Then we are given separation of plate, which is D, and D is okay, and our D is 4 millimeters. Okay, This m for milli is times 10 to the power of minus 3 now in meter. So if you use this formula, you have to make V the subject of the formula because this is what you are asked to find. Simply multiply both sides by D to clear fraction. When you do that, this side you will have electric field multiplied by D is equal to this, cancel this, and you have V. That is, your V is equal to electric field multiplied by D, and the electric field is 120 volt per meter multiplied by your D, and your D is 4 times 10 to the power of minus 3 in meter. You see that? Um, Remember that this V is measured in volt, denoted by capital V. So at the end, you should have this. Per meter cancels meter, and then you have the unit in volt. So finally, multiply this 120 times 4 exponential negative 3. Okay, this will be 0.48. So, and we have 0.48 volts. That's it. With this, I hope you understand the capacitance of a parallel plate capacitor, and you can solve simple problems related to capacitance of a parallel plate capacitor. Thank you for watching. Assalamu alaikum wa rahmatullah.